Vamos entonces a recibir a Ivan, vamos a escuchar su planteamiento, un planteamiento interesante sobre una pregunta muy relevante, es en qué momento nuestras poblaciones latinoamericanas van a llegar a su pico máximo. Él hizo un ejercicio en dinámica de sistemas para estudiar el caso de Guatemala. Entonces vamos a escuchar a Ivan.
Hello, my name is Ivan Taylor, and I'm from Policy Dynamics in Ontario, Canada. And I'm a mentor. My name is Ivan Taylor, and I'm from Policy Dynamics.
Bájale un poquitico eso, y activamos los subtítulos. Ahora sí.
Dynamics in Ontario, Canada. And I'm a mentor for the System Dynamics Society. And I mentor young people all around the world who want to quickly learn the best practices of system dynamics. And so one of the things I do when I introduce someone new to system dynamics is I try to explain how system dynamics works in a simple words. So what I'll often do is I will provide a model of population demographics in their country so they can see basically how a simple system dynamics model works and how system dynamics can be easily understood in terms of a spreadsheet. So I'm going to talk today about sort of an example of this technique, and I'm going to talk about Guatemala since this is for the Latin American System Dynamics Society Conference. And my question is, when will Guatemala's population peak? So the UN projects that the global population will reach around 9.7 billion people by 2050 and peak at around 10.4 billion people by 2100 before stabilizing or declining. Right now, Latin America is still experiencing population growth, although the rate has slowed recently. And as of 2024, Guatemala's population is approximately 19 million. And Guatemala is one of the most populous countries in Central America. The country has experienced steady population growth because it's driven by a relatively high birth rate compared to many other countries in Latin America. However, much like much of the region, Guatemala's population growth is gradually slowing due to declining fertility and high emigration rates. So here's a simple model of population. It has a stock of people, which is called population, and it has an initial value for the population. And then it has three flows. It has a births flow in, a net migration flow in, and a deaths flow out. And the births are calculated by the population times the birth rate, and the deaths are calculated by the population divided by the life expectancy, and the net migration is calculated as the population times the migration rate. So what I often start with one of my mentees is a picture of this model as a spreadsheet. And so here we see years going down the first column from 1950 to 1960. This is actually the data I used in this model for Guatemala. So we have an initial population of a little over 3 million people in 1950. We have 140,000 births in 1950, 84,000 deaths and 1,600 net people coming into the country uh, in terms of net migration. And then the population in 1951 is calculated as the population in 1950 plus the births minus the deaths plus the net migration. So if you were to take the 3,058,000 and add 140,000 births, subtract 84,000 deaths, and 1,600 net migration, you would get a new value of the population in 1951 of 115,000. So, so you can think of a system dynamics model as a spreadsheet where each of the endogenous variables in the model is a column in the spreadsheet. And basically, you do an integration of a differential equation by walking through time, one step at a time, adding the inflows and subtracting the the outflows, times the time step, and add that to the previous value of the stock. So that's called Euler integration solved using numerical methods. So that's how system dynamics works. It's really not that difficult. And I think it's very easy to explain system dynamics like this as a series of columns in a spreadsheet that basically accumulate on a step-by-step basis. So here's the rest of the model. I have now birth rate and life expectancy have changed in the past for Guatemala. I'll show you some of that later. Just a note is that I'll be considering the death rate, and the death rate is equal to 1 over the life expectancy. So it's the reciprocal of the life expectancy. And the migration rate is shown here as well. And basically, I've got a simple goal-seeking model of birth rate, life expectancy, and migration rate, which over a period of time reaches the long-term values from an initial starting point. So this is the model that I used for the three rates in this population model. So I calibrate the model using historical data. So I was able to obtain historical data from 1950 to 2023 from the United Nations Population Prospects 2024 database. And I noted when I analyzed the data that the life expectancy has steadily increased since 1950 in Guatemala. And the birth rates have started to decline around 1980. And the net migration, which are push-pull factors, can be large individually, but when combined, they have a relatively small negative impact. And with these findings from the historical data, I believe that Guatemala is heading for a demographic transition. So here's the historical data. You can see the death rate, which is 1 over the life expectancy, has been decreasing steadily since 1950, which means the life expectancy has been increasing steadily since 1950. And then the birth rate was relatively increasing between 1950 and 1980, and then it started to see a decline, a sort of almost a rapid decline from 1980 to 2020. So I then use this to make projections into the future. And I have a few key assumptions in these projections. The first is that life expectancy has reached a limit at about 72 years. However, the birth rate, I think, will continue to decline, and eventually the birth rate will be lower than the death rate. And the population peaks when the birth rate equals the death rate. So I have three scenarios, a 2040 scenario, where the population peaks in 2040 at about 19.8 million. And then I have a 2050 scenario where the population peaks in 2050 at around 21.6 million. And then I have a 2060 scenario where the population peaks in 2060 at around 22.7 million people. And I'll show you why I chose these scenarios. Here is the historical data between 1950 and 2023. And as I said, I assumed that the life expectancy has reached a limit at about 72 years, which turns out to be this line here at, I think, 0.0138 death rate. And you can see the birth rate declined significantly between 1980 and 2023. And I projected three views, three scenarios where that birth rate would continue to decline for the next, I guess, 50 or 75 years, eventually reaching a steady state below the death rate. And I chose the birth rate of the United States as an example of the long-term birth rate that I would expect Guatemala to eventually get to. Okay, so you see I have three scenarios. I have the death rate, the birth rate reaching the death rate in 2040, and then I have the birth rate reaching the death rate in 2050, and I have the birth rate reaching the death rate in 2060. And this developed into the three scenarios of population growth. And you see the historical data between, well, this is a smooth curve of the historical data between 1950 and 2023, and then the three projections of population in the 2040 scenario, in the 2050 scenario in orange, and the 2060 scenario in gray. And you can see that in the 2040 scenario, the population peaks in 2040. In the 2050 scenario, the population peaks in 2050. And in the 2060 scenario, the population peaks in 2060. And that shows how I got these estimates of the population extended into the future. And notice also that after the peak, there's a steady decline in the population because the birth rate after it peaks is lower than the death rate. Okay, so the key findings from this model and this data is that I believe the population will peak most likely around 22 million people in 2050. And we saw in the data that life expectancy has seen significant improvements since 1950, but will obviously reach a limit. And I chose the limit of 72 years. It was arbitrary, but I think that's reasonable. Also, too, birth rate decline has happened in recent years, and I feel this might be caused by education and economic opportunities for women, which influence and reduce the fertility rates. Basically, education will allow women to practice contraception, and economic opportunities may encourage women to delay childbirth until they have their career established. And so that may also reduce fertility rates. Also, migration dynamics. There are very strong, I know there's very strong push-pull factors of migration into and out of Guatemala, and they could be significant in the long term. Right now, we haven't seen it, although it is the emigration is getting larger, and it is causing some reduction in the population. It's really small in comparison to the birth rate and the death rate. So future research, I'd like to, refine the projections by incorporating more detailed models of migration and basically the push-pull factors involved in that. I think we should also have better models of the subjective factors, the personal decisions around family size and emigration. And then we should also look at population and sustainability, aligning the demographic trends with Guatemala's development goals. So thank you for your attention, and I look forward to your questions. You can reach me at any time at ivan@policydynamics.ca. And if you would like to get mentoring from the Systematics Society, you can look at the Systematics Society webpage under training and mentoring, and you can go to the one-on-one mentoring, which I am specialize in, and you can ask for me to be your mentor if you wish. Okay, so again, thank you very much for your attention, and I look forward to your questions.